Good morning everyone, welcome back to Question a Day. Today we'll be answering the July the 17th question on roots. Here we have an equation, p minus 1 times x squared plus 4x plus p minus 5 is equal to 0. This is a quadratic equation. P is a constant, and we're told that this equation has no real roots. First thing we're asked is to show that p satisfies this equation. So we're dealing with a certain amount of roots, and hopefully what topic this should be screaming at us is discriminant. So if we remember the discriminant of a quadratic equation, is the following expression. It is b squared minus 4ac. That is the x term squared, take 4 times the x squared term times the constant term. And we had some different conditions. So we had, if it was greater than 0, that means there is 2 real roots. If it's equal to 0, well, it was a bit slightly weird how we said this. We said that there were 2 repeated roots. Technical reason behind that, we don't need to worry about it. There is a reason this is, but yeah. And lastly, if it's less than 0, there are no real roots. Okay, not quite giving ourselves enough space there, but that's the kind of rule we're working with. Is b squared take 4ac, and depending on what it equals, will tell us how many roots a quadratic equation will have. So let's look at this. We have this quadratic equation, and we're told that it has no real roots. Well, that's our third condition. So we know that b squared, take 4ac, whatever it is, has no real roots. So this expression must be less than 0. Now all that's left to do is substitute in our values up here. So we get b being equal to 4, so 4 squared, take 4 times p minus 1, p minus 5. And we know that that is less than 0. We'll expand this out and try and simplify it. So 16, take 4 times, well, this is going to be p squared, take 6p plus 5. That's less than 0. So we've just expanded that using whichever expansion method you prefer. We'll do a little bit of simplifying. I've noticed that there's a factor of 4 in both of these. So I could divide both sides by 4, and that should leave us with the same result. So we get 4 minus p squared, take 6p plus 5. It's less than 0. Now, a little bit careful here. We've got a minus inside a bracket, so we don't want to accidentally flip signs when we don't want them to. So we get 4, take p squared, plus 6p, take 5, it's less than 0. Okay, that's going to become negative 1. So negative p squared plus 6p, that's 4, take 5, it's negative 1, it's less than 0. We'll move everything over to the other side, so we'll add p squared, take 6p, add 1. We get left with 0 is less than p squared, take 6p, plus 1, which is what we wanted up here. Okay, so that's part 1 of this question done. Put a nice underline there. The second part of this question is asking us to find the possible values of p. Now this is our solving inequalities and finding those. Now, if you remember, you can do these on your calculator. There's an inequalities function there. We'll do this by hand just to demonstrate how it could be done, but you can use your calculator for this. Okay, so we're going to look at p squared minus 6p plus 1, and we're going to look at possible solutions to this. So we could, now looking at this isn't going to factorize very nicely, so perhaps it would be better to use our calculator for this. But we could also look at it as a discriminant, not a discriminant, sorry, a completing the square. We can look at this as a completing the square. So we can take this expression, we can try and complete the square on it. Remember, when we're completing the square, we take this p squared takes 6p. We're going to half this negative 6 and put that in a bracket. So p take 3 squared. So when we expand this out, we'll get p squared take 6p, and we'll be left with, we'll get a plus 9 there, so we want to get rid of that. We'll add 1. Again, there's questions available and examples available to help you if you're not quite sure where this came from. Rearranging this, we should get that that becomes negative 8, so we'll put that over to the other side. So we get 8 is less than p take 3 squared. We'll take a square root of this, and this is going to give us that weird kind of inequality sort of thing. We could think of this as a quadratic graph, for example. P minus 3 squared is going to be a quadratic graph that looks like that, with a root at 3. And we want to know if we say that this graph is, so this is our p minus 3 cubed, p minus 3 squared line, and this is our 8. We're looking for where this p minus 3 squared is greater than 8, which is on this side and this side. So we're going to generate two separate inequalities when we take this square root. Again, your calculator will kind of do this entire thing automatically, but it's still good to know how to do. So we sketched out our quadratic, looked at the two sides, and we're going to say, well, the square root of this will tell us that p take 3 is either going to be less than, this is the negative side of this square root. So remember, the square root has a positive side and a negative side. So it's going to be negative root 8, or p minus 3 is going to be greater than the positive square root of 8. So that's where those 2 points lie. Okay? And last of all, we can rearrange this and get that, well, p has to be less than 3 take, well, root 8 is 2 root 2. So that's just simplified there. Root 8 goes to 2 root 2. Or p is greater than 3 plus 2 root 2. And there you have it. Again, your calculator will kind of do that for you, but that is how you would calculate that.